because they're so dehydrated, or having to, at the end of seeing 30 plus patients and dying to get out of that suit, only to hear the nurse shout out, "Doc, this patient is unresponsive." Then having to run over there to do chest compressions, bagging a patient for another half hour, when all you could do is think about getting out of there, and the very fibers of your own soul are stretched so thin that you yourself are on the verge of passing out from exhaustion. It may seem like this is an exaggeration of the narrative. However, I've actually gone through this. I've actually had a colleague rather, pass out on the COVID ward while actively tending to a critically ill patient. And it was only the grace of God that allowed another colleague to be coming onto the ward at that very same time. And all they could do was just drag him off of the ward to safety, where he could get the help that he needed. I want you to come with me as a care provider, the one who you come to when you aren't feeling well and you want answers, the hero. As a relative brings the patient, their loved one, to the hospital, expecting to be made well, to be fixed, to then be asked the timeless questions. "Doc, do you think he'll make it? Do you think she's gonna be okay?" And you know in your heart of hearts, the odds aren't on their side. Whether grandpa is 85 and has hypertension or diabetes or a heart disease, or a young lady who is obese with asthma. But you say, yes, we're gonna do the best for them, as a form of comfort to a grieving family whose only desire is to see their loved one back out on the other side of that isolation window again very soon. And you, in fact, think that they may turn around because they were only on a little bit of oxygen, or they didn't look too bad today, only to hear overnight that they deteriorated rapidly and eventually succumbed to the battle. Meanwhile, also being faced with a dilemma of having 2 or more very ill patients with only one high flow oxygen machine available, and having to decide which person needs it more, or worse yet, not having any ventilators or high flow oxygen machines available at all. Or how about hearing that your own colleagues, no medical illnesses, young, fit, and healthy, catching COVID and ending up in hospital, on oxygen, or even in the ICU, fighting for their life? The emotional turmoil is all too real for us as doctors, nurses aides, and other healthcare providers, who, after having to deal with this for 12 hours a day on any given day, the agony of delivering bad news, taking care of ill and dying patients with sometimes nothing else that you can do for them, to then have to go home to a family who you are scared to death of even seeing, touching, hugging, or kissing because of the risk that you might bring this disease home to them. Or like for me, when I said goodbye to my family in March 2019, when I visited home last, with every anticipation of being home for Christmas, only to know that the next time that I would see them would be 2 whole years later because of a pandemic that separated us for more miles than actually existed between Cayman and Jamaica. The mental, emotional, and physical stamina that it took to get me through this past year has been nothing short of God's goodness and His grace. His mercy to have kept me, my family, my loved ones safe and well. Despite my mom and grandparents being in Cayman, each of them having medical illnesses that would put them at high risk for severe disease, God kept them. Despite my dad living in New York during the height of it all, in March of last year, when I received a dreaded phone call to say, "See, I'm having a fever and a bad cough." And he said he contracted COVID, ended up being in the hospital. Me being unable to get to him or even see him other than on a WhatsApp video call, seeing his worn down body, literally barely able to say hello when he answered the phone, on oxygen and fighting for his life. God kept him. I can truly say God has kept us all. And while I know there are people who have lost loved ones, people who didn't make it to tell the story, there are those who can tell of God's goodness and his protecting and miracle working power. And for this, we continue to fight. While my aim was not to have you relive my experience, as all that I've said has been my firsthand experience, it was really just to share with you the dire situations we face every single day caring for patients on the wards, personally as well as collectively. Everyone had a fight. Everyone had a story, but everyone has a role, even you. We are all essential workers, essential in the fight against COVID. We all can do our part to flatten the curve. You remember last year, we wondered if there would ever be an end to this. We wondered if this was going to wipe out the population. We wondered if we'd ever be able to see our family, our friends again in comfort and freedom without fear. I can tell you, I rejoiced when we heard that a vaccine was here that may help lessen the risk of severe disease. No, it doesn't prevent you completely from getting COVID, but it does lessen the risk of severe disease. A vaccine that would help me as a doctor have one less person to look at and have to tell them that their relatives succumbed to this dreaded virus, or that I had no ventilator to offer. A vaccine that would allow me as a daughter, a sister, an aunt, a granddaughter, visit my family without fear of bringing home something that may not put me in hospital, but may place them in grave danger. The number of scenarios that played out like that for me were one too many. So I'm thankful that as we all continue to do our part, we will overcome this stronger together. Thank you for having me.
Good evening, everyone. Thank you, Dr. Bass. That was a really powerful narrative of what you've gone through. That is, I hope, something that people really listen to get that perspective. I want to thank Carol, the Booth brothers, for helping to get this together. Thank you to your pastor, Pastor Lewis. It is good to be with each of you this evening. And you've already gotten a really great introduction to what life is like when you're an infectious disease or an emergency room doc dealing with something like COVID. What I will do, it is my goal to actually guide you through a discussion of what the virus is, how it causes disease, what the vaccines are, how they were developed, and safety of it. So at this point, I'm going to share my screen with you. So you're able to see that, and then I will start a discussion here. Okay. So I want to start off with a disclaimer here that it is not my goal to make any sort of money or intellectual property rights from this conversation. I'm just providing information. And secondly, it is also not my goal to force anyone into taking a vaccine or even to come to my way of thinking about this. You've already heard really poignantly about what it feels like to be in the presence of a virus like this. But it's really my goal to give you information so that you can make informed decisions about what it is that is going on and whether or not, when you have an opportunity to take this vaccine, if it's the right thing for you and your family. I want to start by saying that our bodies, both inside and outside, are loaded with microbes. We live in a sea of microbes. In fact, it's estimated that we have about 30 trillion cells that make up the human body, but there are about 38 trillion bacteria that live in and on our bodies. And it turns out that only less than 1% of that actually cause disease. We know about the disease-causing microbes because they affect us negatively. And so we spend a lot of time studying them and trying to interact with them. But we harbor a lot of these microbes in and on our bodies. However, it's just a few of them that we have to contend with. And I like this little poster just for laughs, that whenever you feel sad and lonely, just remember there are trillions of bacterial cells in and on your body, and all they care about is you. It turns out that while most of them will go on living, some of them actually protect you from the ones that can cause disease by competing with them for binding sites on your cells, as well as for food and nutrients. Some of them, however, can turn on you if your immune system gets low. And so having good immune system is important. Now, that number did not include viruses, because researchers are still surveying to find out the length and breadth of the numbers of viruses we have in and on our bodies. But we know that in water, for example, you have tons of viruses in a single milliliter of seawater. So viruses, all different sizes and shapes, from those that infect bacteria, like this bacteriophage one, to ones that are larger, like the coronavirus. We have them all around. And because of that, ever since they started tracking the human population and documenting it, we've always had pandemics. You can see here the Antonine plague all the way back, killing about 5 million people. At that time, that was a significant proportion of the population. That's 166 to 180. And then you can see the bubonic plague. It killed about 200 million people. Again, that's in 1347, going on for a very long time, this plague. And of course, smallpox, 56 million people. So pandemics have always been around. Probably closer to our time is the Spanish flu, that killed about 40 to 50 million people worldwide, 1918 to 1919, misnamed the Spanish flu because the Spaniards were really the ones who were reporting the true numbers. It was that towards the end of World War I, and most countries did not want to tell their population that in addition to dying from the war, having sent soldiers there, they were actually dying from this disease. But because Spain was a neutral country and didn't have a part in the war, they judiciously reported the number of deaths, so it became known as the Spanish flu. And of course, the cholera pandemic that spread from India to Europe to across the pond here into the Western world, killed many, many people. And HIV, as the pandemic continues. But our focus today is on these coronaviruses. I showed you that graph to show you that we have pandemics and then they end. And I hope that gives you some hope that we will get out of this and we will have an end to this pandemic that we're currently in. But our initial interactions with coronaviruses, the NL63 coronavirus, started in the 1960s, the mid-1960s. And a few years later, in 1965, 1967, they discovered more of these coronaviruses. But they just caused the common cold, and it was nothing to worry about, so to speak. In fact, nobody thought enough of them to even give them real names. They got these alphanumeric codes that the researchers who found them actually gave to them. But 3 times now, we've seen lethal coronaviruses jump into the human population. And they typically infect as a reservoir these rodents and bats as their hosts. And they don't cause disease in these bats and rodents that they infect, but somehow they can be transmitted from those into humans. And in 2002, 2003, we saw that happen, where we had the original SARS outbreak, the severe acute respiratory syndrome coronavirus, that's SARS-CoV-1. And it came from bats into civet cats, and then from there into humans, and then it could be transmitted from human to human. And right at that point, they started in earnest to try to find a vaccine against this, because knowing that these viruses can be so readily transmitted, everybody in infectious diseases and immunology knew at the time that a vaccine would be the best way to control this. So you control most big pandemics. But the disease, the outbreak ended rather quickly. It infected over 8,000 people, caused just under 800 deaths. That's a 10% mortality rate. And then kind of just disappeared because they started killing off the civet cats and started trying to quarantine and control the virus. So they didn't get to test the vaccine because you can't test the vaccine if you don't have people who are infected. And so money was poured into still trying to find and develop a vaccine. But over time, that support waned. And then just about the time when people kind of forgot about these bacteria, these viruses, this coronaviruses, in 2012, the Middle East Respiratory Syndrome coronavirus, or MERS, emerged in the Arabian Peninsula region. And it came from bats again into camels and from camels to humans. So far, there has been no human-to-human transmission, but they continue to have transmission from camels to humans. And at this point, it is still ongoing. We haven't heard about it in the Western world because, of course, we don't have camels moving around. But wherever there are camels, this is actually a threat. And the mortality rate for this is right around 35 to 37%. And so, again, earnestly, researchers started trying to develop a vaccine against this family of viruses. And then in 2019, you know what happened? SARS-CoV-2 came about. And what I'm showing you here is a cell that has been infected with the severe acute respiratory syndrome coronavirus 2 that I'll call SARS-CoV-2 from here out. That is the COVID-19 virus. And this cell is actually dying. It's a human cell. You can see this green blob is actually a cell. Typically, it's rounded. But now that it is being attacked by these coronaviruses, which can attach to these cells via receptors that they have, and within 10 minutes of attaching, it actually gets inside of the cells. And 10 hours later, this is what you're seeing. It has over 1,000 viral particles infecting the cell. The cell, realizing that it's not able to control the virus, is actually killing itself through a process that we call apoptosis here. And here's an electron micrograph. You'd have seen images of the coronavirus, but this is actually looking on the microscope at high power. This is false colored, and you can see these spike proteins surrounding it. This is what you see on the virus, and this is actually how it gets its name. Corona means crown in Latin, and that this is what the virus looks like. It looks like a crown that you're seeing here. So currently, we have over 3.7 million people, 3.7 million people worldwide who have died of this virus. A significant number of the population, over 172 million people, have been infected worldwide, some countries more than others. India is undergoing a significant increase in the numbers of people that they're having infected and dying from this virus. Overall, in Jamaica, it's a continuing disease. You have right now a significant number of cases that are active every day. They're new cases, new deaths. 48,000, just under 50,000 cases there in Jamaica that have been confirmed. 960 deaths. Lots of people have recovered overall. Your vaccine uptake there is really just 0.75% of the population. Just about 22,000 people are fully vaccinated in Jamaica. Recently, they looked at excess deaths, total number of deaths over what you would typically see if the coronavirus pandemic wasn't around. And they estimate that the number that I just gave you, the 3.7 million, is actually 3 times that amount in reality, about 7 to 13 million excess deaths worldwide. And you can see that that varies from one country to the next. But essentially what they're saying is many more people have died from coronavirus than what has been confirmed and reported, because there are people who probably died and it wasn't seen. Now, I talked a little bit about that spike protein, and this is an important protein on the surface of the virus. This is a cartoon drawing of the virus, highly stylized, but a cartoon nonetheless. And what you see are these spikes, and each viral particle has about 100 of these. These are important for it because these are the keys that the virus used to unlock the door of our cells to get in. And that door is called the ACE2 protein, angiotensin converting enzyme 2, which is a protein that we have on many cells in our bodies. So we don't get infected with coronavirus because our immune systems are weak or because of anything else that we've done, except that we've been exposed to it. But we get infected because we have a receptor that is like a lock that the virus is able to bind to. Here's the spike protein over here, binding to this spike protein. And that actually helps it to get inside of our cells, essentially. And so that's how we get infected with it. And as what I'm showing you here is that you actually have a significant number of cells in the body, in different organs of the body, from the nasal passages to deep into the lungs, the intestines, the heart, your eyes, even the liver, and then even the pancreas. Pick up on in a little bit, the brain, the placenta, the testes, the bladder, all of them have receptors, this ACE2, that the virus is able to bind to. In other words, this is not just a virus that infects your respiratory tract. It's a virus that is able to get out of the respiratory system into the blood and find other cells that it can actually bind to and get into. And that becomes important because while the lungs are the primary place that you actually have infection symptoms, as you will see in a little bit, people have symptoms because this is a multi-organ, multi-system infection. And Dr. Best actually talks a little bit about how, these patients deteriorate after having trouble breathing. And the reason for that, here's a cartoon of a normal lung. And you take air in through your nostrils, it rushes down into the trachea, into the alveoli. These are sacs, almost like bubble wrap, that you have air exchange. You have cells here that help to exchange oxygen, take up CO2 that you exhale. If you have pneumonia, some of these cells actually start releasing mucus as a way to trap whatever is causing the problem. But essentially, if that inflammation continues, these ear sacs, these bubble wrap-like ear sacs, get filled up with mucus. And that mucus now makes it difficult for oxygen to actually diffuse through it so that your body can get the oxygen that it needs. And eventually, if it gets really bad, then this patient is going to have difficulty breathing and actually have a low oxygen saturation, low amounts of oxygen in the blood, and really need a ventilator if it gets to the worst case scenario. This is actually a 3D model, CT scan, of the first patient that came to George Washington University Hospital who had COVID, and they did a 3D scan of the lung. And what you're seeing here in the yellowish green are actually those areas where the alveoli, those sacs, are filled with mucus. And you can see that it's pretty extensive. And at the time when they took this patient wasn't yet on a ventilator. They had just come into the hospital. This patient actually ended up dying from COVID. That ended up on a ventilator because they just couldn't breathe. But you're seeing here that it's affecting both lobes of the lung and is very extensive. And this is essentially what it causes. Here's a normal lung, and here's a lung that is a COVID lung. You can see all of these white areas are areas that are loaded with mucus because of this viral infection. So this kind of morphology, this kind of physiology is very much characteristic of COVID. Now, people have said to me, why is it that we worry about a disease that kills less than 1% or less than 2%, whatever your number is, that you have heard of people? And I always retort, maybe a little snarkily, that, hey, 1% of 10 is a small number, but 1% of 7 billion people is a lot of people. And you can see that. You can't say that these 3.7 million people at least who have died from COVID is a small number. In Jamaica right now, the case fatality rate, in other words, people confirmed and then died, is just under 2%. So that's not 1% anymore. You look at Italy and it's just under 3%. Worldwide, it's about 2.15%. But the numbers like that, when you take them overall, doesn't really show you the right thing, because when you actually look at people over 80 years old, that number now gets to 20% in Italy. So 20%, not 2 anymore. 14% in China, 15% in Spain, and you could go on and on, 12, 13% in Caribbean. In other words, when we talk about case fatality and how many people are dying, it's an oversimplification to just go across the board, because we have groups in our population who are more vulnerable. If I did it by underlying conditions, you would also say it. We also oversimplify when we only think of mortality and not morbidity. For every patient whose life is saved from COVID because of heroics of doctors like Dr. Best. These patients oftentimes have long-term sequelae resulting from having been infected with COVID. And as you can see, they say at least 80% of people who recover from COVID have at least one of these symptoms. 58% continue to have fatigue 3, 6, 8 months after recovering from COVID. Nausea, still having difficulty breathing and loss of taste and loss of smell and chest pains and headaches and all of that you can think about. Some patients have what they call COVID tongue, these maculopapular rashes that develop on the tongue. You have patients who develop gangrene because COVID actually leads to blood clots in the system, and the small blood vessels, the capillaries are blocked in the extremities, and that leads to cutting off of oxygen. Sometimes these get infected with microbes and you have to amputate. One of the newer things that I've been talking about with people is that COVID actually infects the pancreas. The pancreas is what makes insulin so that you can take up the sugar that we eat. Most of the things that we eat in terms of carbohydrates, they eventually turn into sugars. The beta cells, these are specifically the cells in the pancreas that make insulin, are attacked by COVID and by the virus. And these cells are destroyed. And as a result of that, after a certain threshold has been reached, after a certain number of cells have been just damaged, then that patient now becomes start having problems with insulin uptake. And here's a little short video on this.
Catching COVID, even if you're healthy and don't end up in the hospital, could still lead to other long-term symptoms. We've talked about the brain and long-term neurological issues, even for those who didn't experience serious illness. Now we're learning some people are being diagnosed with diabetes after they get COVID.
Number one, diabetes has been growing rapidly over the last decade. The last thing we need is another reason to increase the number of people with diabetes.
The American Diabetes Association thinks about 14% of hospitalized patients are developing newly diagnosed diabetes. Some of that may be people who didn't know they had diabetes before COVID, but they're also learning the virus attacks the cells that make insulin. Now, you're born with a certain amount of beta cells and never make any more. Once enough are gone, a person develops diabetes.
So essentially, this is a post-COVID diabetes that we're seeing more and more popping up. People with underlying conditions, if you have hypertension and obesity and diabetes, of course, and heart disease and certain lung disease like COPD, your risk is proportionate to these conditions. And if you have two or more of these, then your risk goes up exponentially. And so, again, I think it's an oversimplification. The problem is that as Black people, most of us have some of these diseases more than other people in the population. And then when you add to that, the COVID variants, every time this virus has a chance to infect a new host and replicate, because its sole goal is to make more of itself, it has an opportunity to mutate. And the virus actually has, from a microbiology standpoint, actually has what is called a proofreading system. It's almost like it turn on a spell check in Word. And so it catches its mistakes, unlike HIV that doesn't have a proofreading system. This is a larger virus and it has a proofreading system, but it still makes mistakes. And most of those mistakes are detrimental. In other words, they don't lead to any productive variant that is of concern. But every now and then the virus gets lucky and it actually makes a variant that outdoes the original variant and that can cause problems. Now, the variants have been renamed. The B117 that they initially found in the UK has been named Alpha by the World Health Organization. The 135 strain from South Africa has been named the Beta variant. P1 variant that was first found in Brazil is Gamma. And this B1617 is the Delta. This Delta strain is now spreading pretty rapidly in parts of Europe. This is actually what has devastated India. And I talk about these variants because the truth is that they have additional capabilities. They have the ability to be more contagious. In other words, they probably have more viral particles per milliliter of cough or sputum. They are so that you have more viral shedding. They have increased binding to the receptor, that ACE2 that I talked about. In other words, they're more efficient at opening that lock and getting into our bodies. And some of them are even more stable in the environment, means that they can sit around for a longer time before they infect you. And so if you have any one of these variants in any corner of the world, no matter how remote, it's just a matter of time before it comes to you. So here's a little cartoon to explain to you these spike proteins and how these variants can escape the immune response of even somebody who has been infected before. And possibly, if we get a bad variant, it could even evade some of these vaccines that we have. And that's the fear. So here's your SARS-CoV-2, your virus, and these are the spike proteins on its surface, right? These are the spike proteins. Remember, these are actually keys. This is what the virus needs in order to get inside of our cells. So that's where it binds. So here it is binding to the ACE2 receptor on our cells. Here's the ACE2, here's the spike protein. It binds pretty nicely. But then you can actually have antibodies that are formed. This is our immune response responding to it. And these antibodies bind to the spike protein and actually prevent it from engaging with our cells, right? So that's what this mutant now can redo. So here's your original virus, here's the mutant. Now the spike protein has changed. And that's essentially what we're afraid of. So now the spike protein has changed, and the spike protein is fitting better to the ACE2 receptor than the original one. And now what you have is that these antibodies that originally blocked it can no longer do so because the spike protein has changed. And that is the challenge. So that B1617 variant, Delta, now according to the WHO, this is how it is increasing. Here it is in India, in the UK, and now in the US, it's starting to go up. And it's just a matter, again, of time before you find it in other places in the world. Now, the World Health Organization says that the two public health interventions that have had the greatest impact on the world's health are clean water and vaccines. And I agree. And the Seventh-day Adventist Church as an organization actually has a position on vaccines in general. And they actually put out a statement on COVID vaccines in particular that you can actually read. And I could put it in the chat after I finish this presentation. I give you these slides because I want you to see that what I'm saying is not just my opinion. I'm showing you the science. I'm giving you sources for it. So the SDA Church, the Seventh-day Adventist Church, is in favor of immunization and does not have any theological or religious reason not to encourage responsive immunization programs and their implementation. What that means is that you can't go to your pastor and ask for a letter, an exemption letter, not to get a vaccine because the church doesn't have a position against vaccine. Here's the official statement of the church. The Seventh-day Adventist Church places strong emphasis on health and well-being. The Adventist health emphasis is based on biblical revelation, the inspired writing of E.G. White, co-founder of the church, and on peer-reviewed scientific literature. As such, we encourage responsible immunization or vaccination and have no religious or faith-based reason not to encourage our adherents to responsibly participate in protective and preventative immunization programs. We value the health and safety of the population, which includes the maintenance of herd immunity, which I'll talk about later. Specifically, there's evidence that Ellen White herself got the smallpox vaccine when smallpox was their COVID-19. D. Robinson, who was one of her aides, wrote, "You will be interested to know, however, that at a time when there was an epidemic of smallpox in the vicinity, she herself, talking about Ellen White, was vaccinated and urged her helpers, those connected with her, to be vaccinated. In taking this step, Sister White recognized the fact that it has been proven that vaccination either renders one immune from smallpox or greatly lightens its effects if one does come down with it. She also recognized the danger of their exposing others if they fail to take this precaution." And this was a change in Ellen White, because initially when she saw people coming down with smallpox and other diseases, her stance was to really earnestly pray for them, and through miraculous actions and interventions, some of these people were actually healed. But she realized that so many more actually died. And so when it came to her attention that there was actually science behind these infections and science behind vaccination, she actually pivoted to actually started taking it. And I typically say to people, how vaccines work, and I spent my career teaching immunology and teaching students how vaccines work. But I want to take a little time to tell you why vaccines work as well. So our immune system has two arms, the innate and the adaptive arm of the immune system. The innate immune response is the initial alarm that goes off when something comes into the body. This includes cells like your macrophages and dendritic cells, and some of these cells that are highly phagocytic that will eat up bacteria and viruses. And you actually have cells that turn on an alarm and sends a signal to other cells when viruses infect them. Now, the systems work in a delayed fashion. Your innate immune system is immediate. The adaptive immune system takes time to get turned on. In fact, we know that it starts getting upregulated within 10 to 14 days. It peaks around 14 days. That is why they tell you after you've gotten the vaccine, if it's a 2-shot vaccine, you're not fully protected until after 2 weeks after you've gotten your second shot. And that is why your grandmother and other people could tell you that your common cold will get better within 2 weeks, right around the 14-day mark, because the adaptive immune response is actually where antibodies are produced. Antibodies are not produced as part of the innate immune response. The innate immune response just uses cells and chemical messengers called cytokines, chemokines, and other antiviral and antimicrobial proteins that they're able to put out. So essentially, if the virus is not controlled by the innate system, then when the adaptive system kicks in, then it will control it. So again, time. This is the peak here that you're seeing on this graph is 14 days. So here is the initial introduction of either a vaccine or the microbe. This is initial exposure. We call it an antigen, any foreign entity that comes into the system. The body responds. That innate immune system kicks in, does its part. Part of the innate cells actually present or show these antigen particles to the adaptive immune response. And so your B cells and T cells kick in and antibodies start being produced. Of course, other things are produced as well, but that antibody level peaks around 2 weeks. Now, if you're exposed again, the second time to this microbe, then you realize that in addition to these antibody proteins that were produced, something else was actually produced called memory cells. And these memory cells are there along with antibodies that if you ever get exposed again, what took 14 days now takes a day and a half to 2 days for you to get a similar type of response. And that is why some of us who have gotten the vaccines will tell you that the day after we got the vaccine, especially the second shot, we had a spike in fever, we had chills and stuff. This is the immune system all revved up, because not only is the response faster, but the response is a much larger response. The levels of antibodies produced goes up. Now, here's the thing. It does not matter if you were vegetarian from the womb. It doesn't matter how much you work out. It doesn't matter what your body mass index is. You cannot speed up that 2 weeks. It's just the way we were built. You do not want your adaptive immune response kicking on immediately as you're exposed to a pathogen, because the adaptive immune response gets messy. That's why you have the fever and the fatigue and the headache and all of these things. A part of that is actually the immune response. You wouldn't want to get that every single time you're exposed to a microbe. It would mean that you would be in a constant state of having this type of response. If the innate immune response can control it, you'll have a much milder adaptive immune response and some memory response. So essentially, if you have never been exposed to a pathogen before, if you've never been exposed to an antigen before, no matter how healthy you are, you will only mount this primary immune response. It will take 14 days. The secondary response only comes after the primary response. In other words, you have to go to primary school before you can go to high school, right? That is the system that is set up. And no matter how brilliant you are, you still have to go to primary school. You can't skip and go to high school. Now, if you're vaccinated, the vaccine takes care of the primary response. So that if you actually see the pathogen for real, what you're actually having is a secondary response. Or in the case where you get 2 shots of a vaccine, actually a tertiary response. In other words, your body is ready for this. Why is this important? This is important because what your body actually does is that it produces these antibodies. These are Y-shaped proteins that floods the system. It's like the cheap ammunition of the immune system. It pours out tons of them. One antibody producing cell can produce 1,000 of these per second. And what they do is that they bind to that spike protein that I told you was the key that the virus uses to unlock the door. And essentially then what happens is that you have all of these proteins binding to these antibodies binding to the spike protein, and it prevents those from now attaching to the ACE2 receptor. This is important because viruses like COVID have a relatively short period of time of infection before you actually get really sick and end up in the emergency room and having to see a physician to help you. So for people with mild COVID, here's the virus shedding and infectiousness. I mean, you can transmit it, you can detect the virus, but you see the inflammatory phase, it goes up and it goes down. But look at the time period when it's peaking. It's peaking 7, sometimes maybe 4 to 10 days. Remember, I told you that primary immune response comes and peaks around 14 days. If you're actually going to get really sick from COVID, that's going to happen within about 10 days that you're going to end up being in the ICU, being seen by somebody like Dr. Best. But at that point, your adaptive immune response, the antibody producing arm, is just getting really revved up. And as a result of that, before that kicks in fully, you could actually be dead or so sick that you never recover from COVID. That is why you get vaccines. So right now, there are about 51 vaccines in phase 1 development. So even though we have vaccines that have been approved, people are still working on vaccines. And phase 1 means that this is the first stage of human trials. About 45 to 50 people are being tested for safety of the vaccine. There are about 34 in phase 2. This is where you're still testing for safety, but you're also testing for efficacy. Does it actually work? Can it actually protect you? Are antibodies actually made? How much of them? What are they being made against? And then 30 are actually in phase 3. So these are 90-something vaccines here working really well in these stages coming up to the phase 3. Phase 3 is really the phase where you're testing to see if the vaccine truly works. You're giving it to tens of thousands of people. 30 to 40,000 people in these phase 3 trials, and they're randomly selected. Half of them get to placebo, sugar or water or saline, and the other group gets the vaccine. Neither of the people getting the vaccine nor those giving it know who is who. So it's what we call double-blind, randomized, case-control studies. And so in these cases, what they will do, you'll give these people injection, they go about their business. And after a certain number of people have become infected, you go back and you check who is in what group. Are you having more people in the placebo group than in the vaccine group, or vice versa? And that's how you know if a vaccine works. So 7 vaccines have been authorized. 8 of them have been approved by the World Health Organization to be used. 4 of them have been stopped because of various reasons. So you have various vaccines and various platforms to deliver vaccines, because vaccines are challenging to make and you have to get them in the body in a certain way for the immune system to see them. So the Pfizer and Mrna vaccines are the ones that we have the most of in the US. These are mRNA vaccines, a new platform. We'll talk a little bit about that. And then what you have there in Jamaica, the Astrazeneca vaccine, and I think you're going to get the Johnson & Johnson vaccine as well. The one in Russia that is being used widely is what we call viral vector vaccines. And I'm going to explain what these are in a little bit. And then you have other vaccines like the Sinovac vaccines and the Novavax vaccines that are still in development that are protein-based vaccines. So here's how the Oxford AstraZeneca vaccine works. When they found the virus in January of 2020 that was actually causing COVID, they sequenced it. In other words, they went and looked at the entire genetic alphabet that make up this virus. And through that, they knew which part of that code actually codes for these spike proteins. the spike proteins are very important to the virus. Again, this is what the virus uses to get in your cells. These are its keys. So if you're going to go after a virus like this, you take away its keys, you block its keys. And that's what the principle upon which most of these vaccines are based. So they took that sequence and they made a DNA copy of it, even though it's an RNA, they made a DNA copy of it, and they put it in this adenovirus. And for the Astrazeneca vaccine, this is an adenovirus from chimpanzee. Adenoviruses cause the common cold. And this chimpanzee one, ChAdOx1, doesn't really cause much of anything in humans. They have gutted this virus and prevent it from replicating. So it's a non-replicating adenovirus. And what they did is that they took this piece of DNA here and they integrated it into this adenovirus. In other words, the adenovirus becomes a Trojan horse to carry this part of the coronavirus spike protein genetics into the cell. Now they take this and they multiply these, they replicate these viral particles until you have a lot of them. And that's what they inject in you as the vaccine. When it gets in, it enters the cells because typically that's what they do. This adenovirus knows how to get into your cell. And then it dumps that piece of DNA, its own DNA, with a part of the adenovirus DNA, the coronavirus DNA in it, into the nucleus of the cell. The cell now does exactly what it typically does in the nucleus. When it sees the DNA, it makes a messenger RNA of the genes, and that messenger RNA leaves the nucleus. It goes out into the cytoplasm, where it makes the coronavirus spike proteins. You can see them here. When the immune system sees those spike proteins that are being released, it actually makes an immune response against it. And that immune response is what leads to the production of antibodies. And even the cells that are producing these spike proteins and have spike proteins on their surface get tapped. And now antibodies are made that can actually neutralize the virus. So that's the process of how the AstraZeneca vaccine, and it's also how the Johnson & Johnson vaccine is made and works. The Johnson & Johnson vaccine just uses a different type of adenovirus. It uses a couple of human adenovirus 26 and adenovirus 5 for the Russian one. So they just use different adenovirus. Again, these viruses do not replicate. So after they've done this, they die. The spike protein that is made, it gets degraded by the immune system. So it's not around anymore after a few days to a couple of weeks. You don't find any trace of it, but it essentially primes the immune system to get the immune system going. Now, the mRNA vaccines, and I'm showing you this because the US president has just committed that they're going to send significant amounts of these mRNA vaccines to countries through COVAX, which Jamaica is a part of COVAX. So sooner or later, you might get some of these vaccines. It's a different platform. Now, here's a cartoon of a cell. This purple blob here is the nucleus of the cell. And this is where your DNA lives. In fact, the cell doesn't allow the DNA to leave the nucleus because DNA is quite fragile. It doesn't want the DNA to get damaged by enzymes and other things that are out here in the cytoplasm of the cell. But the DNA actually codes for proteins. That's the purpose of DNA. It codes for proteins. It makes proteins. And so the protein making factory called the ribosomes is actually in this other compartment of the cell called the cytoplasm. So when the cell needs to make a protein, it actually makes a copy of that gene that it wants to make a protein of. And that's what a messenger RNA is. The messenger RNA is a copy of the gene that's going to make a particular protein that leaves the nucleus through these pores and comes out here where it's red, and proteins are made. It turns out that this is a normal process that happens in the cell over and over, multiple times a day. In fact, viruses somehow know this, and that's why they infect cells, because viruses do not have the factory. They do not have ribosomes of their own. So when they come into the body, they use the body's factory to make their own protein. So the coronavirus has about 30 proteins, and when it infects you, it stays in the cytoplasm here, and it uses this factory to make all of the proteins that it needs so it can reassemble itself and give itself 1,000-fold of what it came in with, right? That is important because what they did with the mRNA vaccines is that, again, they figured out the code for it, and they formed a DNA template, and from that they made multiple copies, millions of copies, billions, trillions of copies of mRNA. They knew from previous studies of mRNA vaccines that if you just inject mRNA into a person, into a cell, the cell will destroy that mRNA in a short period of time. And so they needed to protect it. And so what they did is that they encapsulated it. They put it inside of a little bubble of fat called a nanoparticle, a fat nanoparticle or a lipid nanoparticle, and that protects it. But as soon as the lipid nanoparticle is injected, it gets picked up by cells, and inside of the cell, the nanoparticle, the lipid, gets destroyed, and it releases this messenger RNA. When the cell sees it, this messenger RNA that is only coding for the spike protein of the virus, it actually makes that spike protein. Right? It reads that recipe and makes it. I like to describe it this way. Let's say that you had a cake that you wanted to make, special cake, but the recipe for that cake was in a book in your library, and that book is on reserve. So now in order for you to get that book, and I know that in this internet age, it's hard to believe that you'd have to go to a library for a book, but let's say that's what you need to do. You go to that library, the library would be the nucleus, the book would be the DNA, and you go to the book pages, which are the genes, where you find the recipes, right? So you get the recipe for that cake. You don't need the entire book, so there's no reason to copy the entire book, but you photocopy it, right? And you can leave with that. You have to leave the book in the library, but you come out with the photocopy. The photocopy would be the messenger RNA. You go to your kitchen now, where you have the ingredients to make that cake. That would be in the cytoplasm, and that would be the ribosomes. And it makes that protein, make that cake, and now you actually have your cake. So this is how it works. Let me give you an animation of this.
mRNA technology has never been used before in an approved vaccine, but scientists are using it now to combat COVID-19. mRNA, or messenger ribonucleic acid, are snippets of genetic code that tell cells to build proteins. mRNA vaccines take advantage of that protein-building process to trigger an immune response and build immunity to SARS-CoV-2, the virus that causes COVID-19. Instead of using a small dose of live or dead virus like some other vaccines, mRNA vaccines use a tiny piece of the virus's own genetic material. Here's how it works. This is the virus. These are called spike proteins. Scientists have isolated the genetic code for those proteins, a set of instructions that are put into the vaccine so your body knows how to make them. Your immune system won't make an actual virus particle, but it will make copies of the angry red spike protein. In other words, no gray ball, but an angry red spike. Once vaccinated, your body starts making those spike proteins so your immune system will develop antibodies to fight the real thing, SARS-CoV-2, the virus that causes COVID-19. The Pfizer and Mrna vaccines that are created for COVID-19 will be the first licensed mRNA vaccine.
And so people say, oh, you know, that mRNA vaccine is really new. And that's true. It's new in the sense that it has never been licensed to be used in humans, but it's not that new. You know, this is a 1992 publication in the journal Science talking about this mRNA and the ability to actually use it to produce proteins that you need. But more current, this is 2017 in the journal Lancet. This is a reputable journal talking about phase 1 human trial. This is, remember I explained the clinical trials to you? This is phase 1, about 45, 50 people. And they're trying to make a rabies vaccine with the mRNA technology. This is 2019, before SARS-CoV-2, where they're trying to make a flu virus, a vaccine. And here again, they're trying to make a Zika virus vaccine. This is in early 2020, before they made a vaccine against SARS-CoV-2. So this is a cytomegalovirus, CMV vaccine. Again, these are the same companies. Moderna has been working on mRNA vaccine technology it's a 10-year-old company, and that's all it has ever done. So mRNA technology has been around for a long time. I've been teaching it in my class, the mRNA and DNA vaccine technology. And here's a 2018 paper, mRNA vaccines, a new era in vaccinology. In other words, the technology has been around. They've just never licensed a vaccine with it. So it is not exactly true to say it was not around. So what is in these vaccines? What's in this mRNA vaccine? Of course, it has mRNA, that messenger RNA, nucleic acid. It has the lipids. And what keeps the lipid nanoparticle together in a ball is actually polyethylene glycol. So that is in it. It has salts as part of the buffer. that dilutes it, a part of the saline, 0.9% saline, and a little bit of sugar in there as part of the buffer. And that's it. For both the Pfizer and Mrna vaccines, that's what's in them. For the Astrazeneca vaccine, what it has in some salts in it, as well as these viruses, the adenoviruses that gets injected in you. So these are the cleanest of vaccines. They have no preservatives in them at all. But these vaccines do have side effects, right? And so people will feel pain at the injection site. You can have fatigue, headache, muscle pain, chills. I had chills and fever, joint pain. Some people have joint pain. You know, if you actually work out your arm before you get injected with these in your deltoid muscle, many times you don't really feel that pain. So all of these vaccines have similar types of side effects, similar types of sequelae after you've gotten the vaccine. And these vaccines also have different levels of efficacy. In other words, their ability to prevent symptoms and disease from the virus. So efficacy, when you hear about the 91 and 94% efficacy, this is in the working world, and this is a variant, B117 variant, the UK variant, and the Pfizer BioNTech vaccine is a 91% efficacy, Moderna 94. Here's the AstraZeneca at 75, Johnson & Johnson at 72. These are highly protective vaccines. The Novavax vaccine, the Russian vaccine, the Sputnik 5, 92% efficacy, other mRNA vaccines that they have. But here is a variant, the South African variant, and what was 91% is now 69%. 69% is still a very decent efficacy. This is preventing any sort of symptom. In terms of preventing disease, preventing infection, that is less, because vaccines were never really made to prevent infection. They actually prevent disease. The virus actually has to infect you for that vaccinated person to actually work against it. Now, there are reasons why, especially as people of color, Black people who came through slavery and some of the ill treatments from those who enslaved us, doubt some of these things because we've been experimented on in the past. Here is a report of the Tuskegee syphilis study that happened here in the United States in Macomb County in Alabama, where in 1932, over 600 African-American men were enlisted in the syphilis study, and they were never told that the reason we're in the study is to see what happens to somebody that syphilis is never treated. At the time in 1932, penicillin as an antibiotic had just come in use. By 1940, it was widespread use, and they knew that it treated syphilis pretty well. These men were actively prevented from getting that antibiotic. This wasn't being run by some rogue public health department in a state or in a county. This was the Department of Health and Human Services, a federal agency that ran this study, causing death to many of these men, infection of their family members, and great morbidity and mortality from this syphilis outbreak. In fact, it's actually what caused us to have what we call the current IRB, Institutional Review Board approval, the way you have to get approval to actually do a human study. And then, J. Marion Sims, those in medicine will probably have learned about him in medical school. He's the gynecologist who is known for developing a lot of the protocols and procedures that we have in modern gynecology. But essentially what you're seeing in this drawing is that J. Marion Sims actually tried out those techniques on slave women without anesthesia. Because at the time, the thought was that Black people just couldn't feel pain. They weren't humans. And so the exploitation of African-American. And then Henrietta Lacks, this African-American woman in Baltimore County, went to Johns Hopkins University Hospital Medical Center, one of the elite hospitals in the world, because she had cervical cancer. And cells were removed from her and became the first widely distributed cell line. And I have these cells, the HeLa cells that I grow in my lab now for research. I had to pay just under $400 for 1 milliliters of it when I bought it. And they made billions of dollars off her cells. And yet her family died in poverty. They were exploited and were never told that this was happening. And just more recently, Dr. Susan Moore, who some of you might have seen on social media, she's a physician, medical doctor in Indiana, who was treating COVID patients like Dr. Best was. Unfortunately, she became infected with COVID. And when she went to the hospital, she was treated very differently from her white counterparts who were in the hospital being treated for COVID. She knew what she should be getting. She begged for it, and oftentimes it wasn't given or it was delayed, and she ended up dying from COVID. When we see these things, when we see ourselves being treated differently, when you're in the hospital and you ring the bell, the call bell for a nurse or for a doctor, and they don't come, but the person beside you calls and they come, and you notice that that person has a different skin color, you learn to distrust people where these things are concerned. So I'm acknowledging that there can be hesitancy in getting a vaccine because of that lack of trust. Now, as of today, over 2.09 billion people worldwide have been vaccinated. And I show this slide for a few reasons. Number one, this is actually 1/3 of the world's population that has been vaccinated. And so for people who say, oh, this vaccine is killing so many people, with billions of people vaccinated, if people were dying from these vaccines, nobody would have to tell you, you would actually know, right? So that is a false narrative. The other thing is, sooner or later, with this many people being vaccinated, we're going to reach the point where we're able to get a handle on these viruses. The Cleveland Clinic is one of the most recognized hospitals in the world, and they did a study. They looked at the recent infections that they were getting for COVID, and what they showed was 99.7% of recent COVID infections in the Cleveland Clinic among caregivers was from those who were not vaccinated. Right? In other words, only 0.3% of people who were vaccinated actually got infected. This is a significant set of data, because what it says is that this vaccine is 99-point-something% protective against getting infection. Here's another study showing you people in a healthcare setting in Texas who were not vaccinated, 2.61% getting infected. One shot of either the Pfizer or the Mrna vaccine, and that number dropped down to 1.82%. And then after both vaccines were given, only 0.05% of people turned up positive. In this case, they only knew that they were positive because they were actually testing them on a weekly basis. They would never have known where symptoms were concerned. And the part that actually gets me, I showed you that people 80 and over are the most vulnerable in the population when it comes on to having COVID and dying from it, dying from COVID. And this is nursing homes. After the vaccines came around, the deaths in nursing homes plunged. My wife works with nursing home patients, and she's the first to tell you, in the early days of COVID, she was on the front line. She's like, Dr. Best, and every day she was coming home saying another patient had died from COVID. Now, there have been prominent people, including pastors, like this pastor from Virginia, who said God is larger than this dreaded virus, which God is. But because of that, he didn't take any precautions, didn't want to get a vaccine, didn't want to wear masks, ended up dying from this virus. Here's a state trooper, actually a sheriff deputy in Denver, Colorado. This is very recent, was posting. I remember seeing his post on Twitter, calling the virus a hoax and the vaccine. He called it stuff that's going to turn all of us into some other type of animal. He actually ended up dying from it. I could go on and on. There are people who have doubted the legitimacy of this pandemic and have doubted the efficacy of these vaccines, and many of them have actually ended up dying. What we're going for, as I wind down, is what we call herd immunity. The idea is that if most people in your community are vaccinated, the probability of you getting infected, even if the virus is still circulating, is low. And this virus will still continue to circulate in some form or another. It likes us way too much to leave us alone. It infects us way too easily. So here's an animation. I want you to keep your eye. 5%, 30%, 75%. If you have just 5% of people vaccinated, which Jamaica doesn't even have 5% of people vaccinated, the probability of having an outbreak, especially if you have a variant that's more contagious, is very high. If you have over 75% of people vaccinated, the chance of an outbreak is much lower. But if you have a variant that is way more infectious, look at that. Even having 30% and 75%, you still can have significant outbreaks. So herd immunity is getting to a place where you have probably over 75, maybe about 75 to 80% of your population vaccinated, where essentially what you do is that you create this kind of a fire break. When they're planting modern forests now, They don't just keep planting trees endlessly. What they do is that they plant a section and have a break where there are no trees that they constantly clear. And then they have more trees over here. What that means is that if a fire breaks out here, that this part will probably be completely burned before they're able to put out that fire, but it won't be able to jump to these other areas. In other words, you're containing it. And that's essentially what you're doing with this with COVID-19, where vaccines are concerned. If you get to herd immunity, that's what happens. Now, I have to admit that even with vaccines, you can still get infected. None of these vaccines are 100%. And if you get infected, some people, depending on underlying conditions, might still end up getting really sick. We're seeing that the probability of that happening is very low when you get vaccinated with any one of these vaccines. So somebody has cleverly described as having this Swiss cheese model, where no layer is completely foolproof. Wearing a mask is a good thing and social distancing is a good thing. And those are still the best thing to do if you haven't been vaccinated. But by themselves, they won't 100% protect you. Washing your hands, also a good idea. Staying away from crowded areas, avoid touching your face. All of these are good things, but by themselves, they don't protect you 100%. Having good ventilation if you have to be indoors. You know, having good testing and tracing capabilities. Having the vaccines. But it's still a Swiss cheese model. No one thing is 100% protective. And I'll stop here and hopefully Dr. Bess and I can take some of your questions that you might have. Yes, Zara and company will.
Okay. Thank you so much, Dr. Webley, for that presentation. Now we're going to get into the questions from our chats and YouTube. So I'll start here. I see two questions from Heezy on YouTube. So is COVID-19 an engineered or natural virus? And he also asks, does hydroxychloroquine or ivermectin work if used early?
Neither ivermectin nor the ivermectin question is still one up in the air. But hydroxychloroquine has been proven repeatedly through several studies not to protect you from progressive COVID-19 disease. Ivermectin was an antiparasitic drug that has been very successful in treating parasites. To date, the only thing that has been published that suggests that ivermectin has any efficacy against coronavirus is when they use 60 times the human safe dose of it in tissue culture. In other words, not in humans, but on cells in a dish in a lab. And that's actually what people have used as evidence to run with this ivermectin idea. Now, there still needs to be clinical trials on it, but none of the trials so far has proven that ivermectin actually works.
Okay, thank you. And his other question was, is COVID-19 an engineered or natural virus?
There's nothing about this virus that says it was engineered. Now, it's likely, and then people are now investigating if it actually escaped from a lab. That's very different from having it engineered. I've looked over the code of the virus. I've seen, you see, we have a few tricks up our sleeves. As an infectious disease person, I can engineer a virus to be more contagious and more infectious than it is. You know, we have the capabilities to do that. Of course, ethically, we wouldn't do that. But you can do that. But if I did that, one of my colleagues or anybody else who has the same expertise would be able to look at it and know that I did that. Because I would have to use specific tools to do it. And because of the tools that I would have to use to do it, that would actually betray what I've done. We haven't seen any of that code in COVID-19. COVID-19, from what I can see, came from an animal, and then we got in the human host. How did it actually make it into the human population? The jury's still out on that. It could have been that somebody was testing it in a lab and then got infected and came out of the lab and infected somebody else. They're actually looking at that theory now in China. I doubt it very much. And the reason why I doubt it is because we've had coronavirus outbreaks before, and all of them came from bats to humans. We've never had one that jumped out of a lab, but that's still a theory that is up in the air.
Okay, thank you.
Okay, thanks for that. And Next, we have from Zoom, Ms. A is asking, what's the source of the lipid that encapsulates the protein in mRNA? And we can also just look at this question from the chat from Wendell Wilkins. Can a fully vaccinated person carry the virus and spread the virus to others?
Yeah, so the lipid is actually a lab-made lipid. So these companies actually spend a lot of time making these lipids. Of course, they have the raw materials for those, but they actually make these lipids, and some of them are proprietary lipids. They're still studying to see if an infected person can actually transmit the virus. What we do know from studies that have been done, mostly with the Astrazeneca and the Pfizer vaccines, is that they've actually swabbed the nostrils of people who had the vaccine and then tested positive for COVID-19. And these individuals had significantly lower amounts of viruses in their nostrils. Here's the tricky part, Zara. We don't know how many viruses it takes to start an infection in a human yet. Because we're still early days in this pandemic. And until we know that, we probably won't fully know if somebody who is vaccinated can actually transmit the virus. But at this point, it seems that the probability of that happening is pretty low, but not impossible.
Okay, thank you. And
another question from Heezy. Should we expect a cytokine storm in the colder months in vaccinated people?
Vaccinated people don't get a cytokine storm. The cytokine storm comes from the virus infection. What a cytokine storm is when you get infected, our cells in our bodies communicate with each other via these proteins called cytokines. So that's what the cytokine storm is, right? So the way we text each other, that's how cells text each other. Their text messages are actually cytokines and chemokines. You get a cytokine storm when so many people are texting at the same time, and it overwhelms the person receiving all of those texts, so to speak, right? That happens when you get infected with the virus. In fact, for people who turn up with severe COVID, we know that that's what's happening. So that's really the immune response. And I describe it this way. Typically, the innate immune response is supposed to hold the viral numbers down to a level where once the adaptive immune system kicks in, you can get rid of the virus. What we've seen in a lot of cases, especially severe cases of COVID, is that the response system that the body uses to warn the rest of the cells around that the virus is around, COVID actually disables that. It's called type 1 interferon. That itself is a cytokine. So COVID make that not as expressed as it should be. In other words, it's like you turn on your alarm system in your house. You know you did that before you went to bed, and then you wake up and somebody is in your bedroom standing over you and no alarm is going off. And so when you see that now, you get so surprised. You do everything to protect yourself. You throw your pillow at the person. You throw your bedspread at them. You throw your Bible off the nightstand at them. You throw your slippers. And that's essentially what starts happening with the adaptive immune response once it kicks in, because it now becomes frantic in trying to protect you. And that now becomes a cytokine storm. When you get vaccinated, especially after the second vaccine, yes, you have cytokines released, but it's not a cytokine storm. So vaccinated people don't have a cytokine storm. That results from the infection of COVID.
Okay, thanks for that. And from Facebook now, we have Mindy Natalie asking, why no emphasis on building the immune system per the CDC? And then she also had a question that's similar to one we asked before. What is the source of ingredients used in the vaccine?
Yeah, so I think I showed on a slide in that presentation all the ingredients in the vaccine, right? So I said that these vaccines have no preservatives in them. It has the messenger RNA. For the Astrazeneca, it has the virus, the adenovirus that is used as the vector to carry the stuff in, and that is in a buffer, basically a salt, sugar, water mix, plus polyethylene glycol, which actually keeps the membranes together. So that's really the what is in these vaccines. Overall, though, essentially, it's not that nobody's talking about building the immune system. The assumption that Mindy is making is that you get infected because your immune system is not working properly. That's not true. What I've shown you is that you got infected because you're a human being and you have ACE2 receptors on your cells. That doesn't mean your immune system is not important. having a good functional immune system, and the CDC says that all the time, eat right, sleep, drink water, having those things, but none of those things, except through a miracle, are going to protect you from being infected with COVID-19. So why emphasize that over emphasizing the fact that you need to social distance, wear a mask, and get the vaccine when it's available, right? So that's why I don't overemphasize that. It doesn't mean that I don't believe that that works. I think a lot of people who got COVID and were able to survive it is because they had a good immune system and no underlying conditions. But that didn't prevent them from getting infected. That didn't prevent many people from getting sick. And we have to separate those two things. As Adventists, we run into a little problem because we firmly believe, many of us, that if we follow the health message, we're not going to get infected by these microbes. Well, if that was true, then God wouldn't give us the gift of healing because we wouldn't need it, right? But we see in 1 Corinthians chapter 12 that among all the gifts that God gives, he gives the gifts, not even one gift, the gifts of healing. Why? Because people do get sick. And infectious diseases are one of those things that can kill you in such a short time that you do need help. Here's the thing, Zara, we get sick and have disease only because the immune system gets overwhelmed. Only. In fact, when you get an antibiotic for a bacterial infection, what the antibiotics do is that they don't clear the bacteria out of your system. What they do is that they get the numbers of bacteria down to a manageable level. And then the immune system takes care of it, right? It is your immune system that cleans up all of that, including the dead bacteria, and get them out of your system. So a functional, good functioning immune system is always going to be your best bet. However, it won't protect you from getting sick and dying many times if you get overwhelmed, if the dose of infectious particles in your system is of a certain amount.
Right. Okay, thank you. So some questions from YouTube, from Isaiah Sims. Can the second vaccine be a different brand from the first? So I assume he's talking about your second dose.
Yeah, so ideally it should be from the same type of vaccine that you got, right? Because that's the way they were tested. At this point, the UK is doing some studies, and I think the US just started doing some studies of mixing and matching that. Let's say you got the Astrazeneca first. Can I give you a dose of the Johnson & Johnson? And then that will put you over the top. Or if you got the Pfizer vaccine first, and then I give you AstraZeneca, or vice versa, will you be fully protected? However, those studies haven't been reported on yet, right? They're still doing them. The studies that have been done, the clinical trials that have been done, says that you get one shot of AstraZeneca and then you get the second shot after a certain time. And that's what gives you the level of protection that I just showed you that has been tested for. Until those testings have come in, my advice would be that you get the second shot of the same vaccine that you got the first time. It doesn't mean that it's unsafe. It's not a matter of safety. It's a matter of efficacy. These vaccines have been proven to be safe. It's not going to kill you. It's not going to cause harm, so to speak. It's just a matter of, is it as efficacious as you needed it to be?
Okay. How safe
Okay,
is...
thank you for that.
Thank you.
Oh, sorry.
Sorry. Shelly Ann Coombs, how safe is the vaccine for pregnant and nursing mothers?
Yeah, so the vaccine has been given to plenty of pregnant and nursing mothers. And one of the good things with the nursing mothers that they've seen is that they actually passed on these antibodies to their babies who at this point can't be vaccinated. And the antibodies actually protect these babies. So it's safe for pregnant and nursing mothers to get these vaccines, all of them.
Okay, thanks. And then we had an earlier question was about efficacy. So similar to that, this person on Zoom is asking, I've read that the efficacy is measured in a 2-week period, beginning 2 to 3 weeks post second dose of Mrna Pfizer vaccines and first dose of Johnson & Johnson vaccine. In other words, if one did not contract COVID in this 2-week period, the vaccine was considered 100% effective or efficacious. Can you speak to how efficacy is measured specifically for the COVID vaccine?
No, efficacy is measured starting at the 2-week mark, right? Not within the 2-week mark. Because remember that I told you that your immune system takes 2 weeks to fully ramp up for this adaptive immune response. That's 14 days. So they start measuring efficacy after that. They have started, they do measure efficacy after the first dose of certain 2-dose vaccines, just to see what the efficacy of the first dose is. But that is measured as far out as the researchers want to take it, right? So 2 weeks after you've gotten the first shot, from there on. And so people have been measuring that efficacy now going 6, 8, 10 months, depending on when people actually got that vaccine. So that's how efficacy is measured. And efficacy really is not what you're going for where vaccines are concerned. Efficacy is really looking at, are you having symptoms after getting a vaccine and then being exposed to COVID-19? That's not the true measure of the effectiveness of vaccines. The effectiveness of the vaccine is how well is it able to prevent you from getting hospitalized and dying? That truly is the test of the vaccine. So getting infected, I might get infected, and right now I get tested every week for COVID. So if I test and I become positive, it will show that I was positive. But the question becomes, am I ending up in the hospital? Am I going to die from COVID? And what the data has shown is that the probability of that happening is way, way low. In fact, there's a 97 to 100% effectiveness as protecting people from hospitalization and death from COVID after taking these vaccines.
Okay, Jennifer Williams asks, based on studies so far in the pandemic, what was the most popular underlying illness patients who died of COVID-19 had? Hypertension,
diabetes. Those were the most common ones. And oftentimes people who have diabetes also have hypertension. So they go hand in hand. Most people have high blood pressure, also, have diabetes, also have high blood pressure. And so those are the major underlying conditions that have led to death in COVID.
Okay, and also quickly, Camille Stafford, there is a rumor that the vaccine is magnetic. Can you confirm or deny?
Total hoax. And here's the thing. If you've ever taken a physics course, you know that if you have a magnet, the size of the magnet is important in terms of strength, right? So I can have something magnetic under my skin and I can put a magnet on it and I won't be able to tell that because it won't hold. In other words, you have to have a large enough magnet under the skin and a strong enough magnet on the outside to actually detect it. Now, the little videos that I've seen going around, what they show are these weak magnets, these play magnets that they're putting. And one of the things I haven't seen is I'm yet to see when somebody put the magnet on their arm, I'm yet to see something under the skin gets pulled out, because that's what happens when you actually have something magnetic under the skin. When you put a magnet over it, you can literally tell the shape of the thing that you have under the skin because it pulls it right up. You're not seeing that here. This is their way, Ariel, to say that, well, there are microchips in the vaccines. And so that's what you're pulling out. That's really what that is getting to. Now, I want you to think about that a little bit, because I just showed you that these vaccines, the mRNA vaccines is what they're saying this about. These vaccines are nanoparticle vaccines. Nano is 1/billionth of a meter, right? That's what nanoparticle describes. That's the size. You can go look it up. Micro is 1/millionth. So you're saying that the government is putting a nanochip in a microparticle vaccine. That's impossible, because a microchip is 1,000 times the size of a nanoparticle. More than that. So none of that is true.
Okay, so we also had some other concerns about the vaccines. Some persons are asking on Zoom, why do fully vaccinated persons become reinfected with the virus? And why do people die from these vaccines? And they also want to know which vaccine you took.
Yeah, so I took the Pfizer vaccine. So did my wife and our sons. So let me address the last part of that first. It is not true that people are dying from these vaccines. I showed you the numbers, right? 2.09 billion people vaccinated. If people were dying from these vaccines, nobody would have to tell you. In fact, where I am in my state of Massachusetts, over 60-something% of people have already gotten at least one dose of these vaccines. If people were dying, I would see them every day, because literally everybody around me that I know has been vaccinated. So this is simply not true, right? People are not dying from these vaccines. There were a few people, 1 in a million people who had gotten the Astrazeneca and the Johnson & Johnson vaccines, women below the age of 50. 1 in a million of them developed blood clots. And initially, I think 20 people worldwide had died from those blood clots. Now, since doctors know that some of these blood clots can develop, they can mitigate it, and nobody has died from that. But where the other vaccines are concerned, nobody has died from the vaccines. Here's the trick. People get confused with numbers, right? This is simple math. There are 3 million people approximately living in Jamaica. If I take some nice roast breadfruit and I pass it out to 1 million people, within 2 weeks of passing it out to those 1 million people in Jamaica, randomly at all ages, probably 35 of them will meet in a car accident. Another 1,400 and something will die within that period of time. Others will become deathly sick and in the hospital. Are you going to say that because I gave them roast breadfruit, all of this has happened to them? Of course not. It's a numbers game. Because you're involving so many people, roast breadfruit doesn't prevent death from car accidents and from old age and from heart attacks and from all of these other things. Neither does the COVID vaccine. COVID vaccines don't prevent people from having heart attacks and dying from other illnesses that they might have. So of course you're going to have people who get the vaccine and die after the vaccine. But to say that they died from the vaccine, you'd have to show a medical pathology condition that the vaccine caused that led to the death of that person. And so far, all of the investigations have shown that that doesn't happen, right? I forgot the first part of the question. Ariel. You're muted.
That was Zara, actually. Zara.
Oh, sorry.
Oh, yeah. I think the first part of that question had been about reinfection. Why do fully vaccinated people become reinfected?
Because vaccines are not 100% efficacious, and vaccines don't prevent you from getting infected, right? So you can, if you're exposed to enough viruses and you're vaccinated, you will become infected. That's why I say efficacy is not the thing. No vaccine that we have, you name the vaccine, the MMR vaccines, you know, mumps, measles, rubella, you name them. None of these vaccines prevent you from getting infected, right? Because vaccines don't do that. Vaccines don't create a bubble around you. What they do is that they prevent you from getting sick and dying from the disease. The vaccines do that. Moreover, no vaccine is 100% at preventing you from getting that. So these vaccines are 90-something%, 80-something% effective at protecting you from hospitalization and death. There's still going to be people, if you vaccinate enough people, who will still die. But what we have shown, and I've shown you in the data, that the vaccines actually protect way more people than that from getting hospitalized and dying from the virus.
Okay, and on that point of adverse effects like blood clots, Heezy asks, can the vaccine penetrate the blood-brain barrier?
No. Again, what the vaccines are is that the vaccines carry a message that makes a protein, and the vaccine is local, right? You get injected in the arm, the cells in the arm, just a little bit of immune physiology, immunobiology. The cells in the arm, your deltoid muscle cells, are the first to engage this thing that you have injected, whether it's the Astrazeneca vaccine or the mRNA vaccines. They're not making it, these viral particles from the Astrazeneca vaccine or the messenger RNA is not making it anywhere far. Essentially, they infect those cells and cells that are along that line, and then they make proteins, and the immune cells that are in the lymph nodes under your armpits actually encounter the protein that they make. And those cells are the ones that start driving the initial immune response, right? They get that protein, the spike protein that these mRNAs code for, and they make that spike protein. And then the immune cells, when they pick up that spike protein, they degrade it. In other words, they destroy it. That's how they know. Because you see, your adaptive immune cells, your T cells specifically, don't respond to whole proteins. In other words, if you take a plate of food and you put it down in front of a T cell, it won't eat it. You have to cut it up into bite sizes and feed it to it in order for it to eat it. That's how the immune system works. The adaptive immune system works. And that's how antibodies get made, because B cells need T cell help to do that. In other words, within a couple of weeks, that vaccine antigen is gone. You can't even detect it in the body. So there's not enough of it left around for it to do anything and cross the blood-brain barrier or do any of these things.
Okay. And next we have, does the mRNA vaccine need more time to be considered safe?
No. So it's a part of the reason that I just described to you, that the protein that the mRNA codes for gets broken down. Now, here's the thing. If the mRNA vaccine is unsafe, because all it's doing is that it's telling the body to make a protein. If that is unsafe, if that's what's going to cause death or injury or damage, every single viral infection that you get would do the same thing. Because every virus that infects you uses your system to read its mRNA and make its proteins for it, because viruses can't make their own proteins. They're obligate intracellular, right? Some bacteria even cause your body to do the same thing. So every single time you get infected, you would have these sequelae. We know that doesn't happen, right? Because so many viruses infect us every day. Most of them are not disease-causing, right? So that is not happening. We don't need extra time. What the FDA, the Food and Drug Administration in the US, went back and looked between the 50 and 100 years from now, 50 or 100 years ago, all the vaccines that have been approved. And what they saw was that there were no side effects from vaccines after about 2 to 3 weeks, right? So, side effects from vaccines are not something that cause long-term issues. Your side effects from vaccine happen very quickly, within hours, within minutes even, to days. And after that, the vaccinate, the thing that you injected, is gone. So it's not around to cause long-term damage.
Okay, and I think our final question from Stafford is, can cancer patients receive the vaccine?
Yes. Lots of cancer patients have gotten the vaccine. Of course, this is something that you should talk with your oncologist and your general practitioner about, because it depends on what stage you are in your cancer treatment. If you're currently having chemotherapy and or radiation at certain doses, you might not make a strong enough response. But the data that has come out has shown repeatedly that cancer patients make very good responses against these vaccines and are protected from COVID. And so it all depends on what stage you're in terms of treatment, not your cancer, but in terms of treatment.
Okay, great. And I'd just like to point everyone's attention to this question in the chat from Teresa Easy. You listed a series of side effects from infection of COVID-19. Will taking the vaccine prevent you from having those side effects of the virus if you get infected again?
Yeah, so that's essentially why you get the vaccine. You protect yourself from having those. In fact, people with long COVID, which is what I was talking about in that graph, I showed that people several months after having gotten COVID have these symptoms that won't go away. What they've seen, and the data hasn't come out fully on this, no peer-reviewed journal article has come out, but what they've shown is a lot of people who had long COVID, after they got vaccinated, those symptoms went away. So you got infected with the virus, you have long COVID, you get the vaccine, and then those symptoms go away. So what it says is that some of the viruses were probably still lingering, and the vaccine actually helped your body to clear them, right? And so that is a good thing. So people with certain autoimmune diseases, cancers, can still get the vaccine. The only group so far, Ariel, that seems to have a problem with making enough antibodies to protect them against the virus with these vaccines, and specifically the mRNA vaccines. I don't think they've looked at the Astrazeneca vaccine at this point, are people who have been have transplants. So transplant patients, kidney, heart, lung, liver transplant patients, all of them have to be on immunosuppressive drugs for their lifetime, pretty much. And those immunosuppressive drugs oftentimes can lead to you not making the type of immune response that you could make to protect you. And so they probably have to look for different vaccines that might be able to boost that response in that population of individuals.
Okay, and I'm afraid we'll have to end here because we need to start Vespers before sunset. So thank you so much, Dr. Webley, for presenting and for answering most of our questions. And now let's start Vespers.
But before you go, Ariel, Dr. Webley, there was a question, and this is Elder White speaking.
Elder White.
There's a question in the chat. If there is any question that you think we should have asked in your experience that you did not hear anybody ask.
I think it's really about some of the conspiracies. I wish people had asked more questions about some of the things that are going around, that the vaccine, for example, changed your DNA. And the answer to that is absolutely not. None of these vaccines are able to change your DNA. As I said, the cell is very protective of the DNA. The mRNA vaccines don't even go into the nucleus, but even if it does, these vaccines can't change the DNA in the nucleus of your cell because the cell has specific mechanisms to actually protect you against that. The truth is, Elder White, that there are reasons for people to have hesitance for these vaccines because they were developed really quickly. And one of the other questions I wish people had asked is, how did they develop these vaccines so quickly? And can we trust vaccines that have been developed this quickly? And the reason they were developed so quickly are about fourfold. Number one, the technology was already there, right? I showed in my presentation that the mRNA vaccines were things that were being developed long before COVID came around. They were literally at the stage where they're being tested in the first and second phases of clinical trials. So that's number one. It's not exactly as new as people think it is. It's a 20-something-year-old technology. Number two, a lot of money was poured into this. If you were a company testing a vaccine, you wouldn't start producing that vaccine while it's still being tested in clinical trials, in phase 3 clinical trials, because your investors would be on you so fast that you're going to lose their money. Because what if it doesn't work out? What if the phase 3 clinical trial shows that it doesn't work? Then you have to dump all of those doses of the vaccine that you're produced. But that's exactly what happened in this case for all of these vaccines, that they were being produced, manufactured the moment phase 3 clinical trials start. Why? Because governments, including the US and the UK and several federal governments, gave them billions of dollars to do this and say, don't worry about it. If it doesn't work out, no worries about the money. So money was not an objective. And then the third thing that was really important is the fact that we're actually in the middle of a raging pandemic where every single day around the world, you are having hundreds of thousands or millions of cases being registered. Typically, clinical trials and vaccine development take a long time because it takes a long time to get enough people infected in the trial for you to see if the trial works. In this case, that happened really fast because the pandemic was raging everywhere. So within what would take 2 years probably for you to see that number, you saw that within 2 months. So they knew if the vaccine was working. The fourth thing and final thing is that they overlapped the different stages of clinical trial. Once they realized that the vaccine was safe in phase 1, they started phase 2. They added more people. Once they saw that the vaccine was efficacious, it was actually leading to antibody production in phase 2, they started phase 3. So while phase 2 was still ongoing, they started phase 3. So that overlap, the emergency use authorization actually allows that to happen. But typically in a regular time period, that wouldn't have happened. No clinical trial company would want to do that.